Hello friends, welcome to the lecture on wells. In this lecture, we are going to see the types of wells and their constructions. So let us start. So what is a well? Well, it is a vertical structure dug in ground for purpose of bringing groundwater to the earth's surface. Basically, wells are classified as follows: open wells, commonly known as dug wells, and second is tube wells. So what are the open wells or dug wells? Open wells are generally open masonry wells having comparatively bigger diameters and are suitable for low discharges of the order of 1 to 5 liters per second. The diameter of the open wells generally vary from 2 meter to 9 meter, and they are generally less than 20 meter in depth. The walls of an open well may be built of precast concrete rings or in brick or stone masonry. Generally, this is called as lining. Their thickness generally varies from 0.45 to 0.75 meter according to the depth of the well. Classification of the open well based on the depth. Based on the depth, open well are categorized as shallow open well and deep open well. So what is shallow open well? These are the wells resting on the water bearing strata and gets their supplies from the surrounding material. And in case of deep open wells, these are the wells resting on the impervious layer known as mota layer, beneath which water lies beneath which lies water bearing pervious layer and gets their supply from this layer. So we shall understand this particular phenomena by with the help of this sketch. As you can see, this is what this is the shallow well, and this is the deep well. Okay, this is the pervious strata, this is the impervious strata, which is also called as mota layer. This is the groundwater table. Here you can see the groundwater level over here. This is the borehole with the help of which water it is directed from this particular pervious strata through the impervious layer and to the deep well. So once again we will move to the definition. So what is shallow open well? These are the wells resting on the water bearing strata and gets their supplies from the surrounding materials. So this well, it is resting on the water bearing strata. So who is bearing the water? This impervious layer is bearing the water and it is rested on that. And deep open well, these are the wells resting on the impervious layer known as mota layer, beneath which lies water bearing pervious layer and gets their supply from this layer. So this is laying on the impervious layer, this is resting on the impervious layer, the deep well. Okay, and this is not resting actually on the impervious layer, it is resting on the water bearing strata. So whatever the soil here, the soil mass will have the water and it is resting on the water bearing strata. Then the classification of open well based on the type of wall. Kacha wells. These types of wells are only constructed when water table is high, as these types of wells sometimes collapses. These are not so popular, they are merely for the temporary usage. Then wells with impervious lining. These are most suitable and stable type of open wells. These are constructed by first digging a pit, then a curb, which is a circular ring with sharp bottom, is inserted, then a masonry wall up to some distance above the ground is constructed, then as excavation proceeds it sinks below, and then masonry is further extended and the well is constructed. As water enters from the bottom, type of flow is spherical. So I will explain this impervious lining, how it is constructed. A circular curb having sharp edges. Initially, on the location where the well is to be dug, initially for a smaller depth equal to the depth of curb, the excavation is done, and further a masonry wall up to a height of say 1.5 up to 2 meter after excavation, it is constructed on the curb. The thickness of the curb is so that it will be equal to the thickness of the masonry wall for the lining purpose. So after curing and casting and curing and having adequate strength, below the curb the excavation is carried, and further since the masonry wall will have the adequate weight, self weight, the curb along with the masonry wall, circular wall, will sink as and when the excavation proceeds, and the process, it is continued further till you are getting the water, and further the excavation is stopped as and when the water enters from the bottom. So this is the well with the impervious lining. As you can see that this is the wall having impervious lining. This is the water level, groundwater surface. This is the clay, water bearing sand formation, and with the help of borehole, the water is entering from the bottom of the well. These are the impervious linings, and these are the curves having sharp edges, as you can see. So initially up to 1.5 to 2 meter masonry wall it is constructed. When the curb is at the ground level location, it is inserted further after excavation, and the self weight of the wall will sink the curb as and when from the bottom of the curb the excavation is carried out. Then well with the pervious lining. These types of wells are suitable in coarse formations. These are constructed by masonry of dry bricks or stones without any binding materials. So the water supply enters from the wall of well, therefore the flow is radial. Such wells are provided with bottom plug, so the flow is not combination of radial and spherical. So as you can see, this is the well with the pervious lining. So material used for the pervious linings are dry bricks or stones. You can see in this sketch, this figure, dry bricks are used for the pervious lining. So here the flow is radial, not spherical. Bottom it is having a concrete plug, and this is the saturated zone. This is the water table. These are the brick ballast, and these are the brick lining. So this is the pervious lining of the well. Then comes tube wells. A tube well is a long pipe sunk in ground intercepting one or more water bearing strata. As compared to open well, their diameter is less, about 80 to 600 mm. So whatever the bore wells we commonly use, these are nothing but the tube wells. They are having high discharge capacity than the open wells. This is a schematic diagram of the tube well. As you can see, they are having very less diameter as compared to the open well, and pumping is done with the help of a pump. Water is extracted with a high flow with the help of a pump. Now the classification of tube well based on the depth. Here also you will see there are two kinds of depths: shallow tube well and deep tube well. What is shallow tube well? These are the tube which has a depth limited to 30 meters and maximum have discharge of 20 meter cube per hour. And in case of a deep tube well, these are the tube wells which have maximum depth of about 600 meters and may give discharge more than 800 meter cube per hour. It is the highest discharge which you cannot achieve in case of open wells. Then the classification of tube well based on the supply system. Strainer type tube well. This is most commonly used tube, such that in general a tube well means a strainer tube well. So whenever you will come across a bore well or tube well, it is by default it is a strainer type tube well. In this type of well, a strainer which a wire mesh with small openings is wrapped around the main pipe, which also has large openings, such that area of the opening in strainer and main pipe remains same. Annual space is left between two strainers so that the open area of pipe perforations is not reduced. The type of flow is radial in this type of strainer type of tube well. You will understand this with the help of these two different diagrams which I have taken from two different books. So by default, any tube well, any bore well, it is a strainer type of tube well. So as you can see here, there is wherever there is a pervious layer, there is a strainer. There is no necessity of provision of strainer in case of impervious layer, because water it is not entering through impervious layer. So it has a very deep depth and it covers many layers in between, which will have impervious pervious layer combination of both. Then the classification of tube well similar based on the supply system. Cavity tube well. A cavity tube well consists of a pipe sunk into ground up to the hard clay layer. It draws water from the bottom of well. In initial stages, fine sand is also pumped with water, and in such manner a cavity is formed at the bottom, so the water enters from the aquifer into the well through this cavity. It is an empty space with a solid object. The cavity, it is an empty space with a solid object. A cavity type tube well draws water from bottom of the well and not from the sides, and is drilled in an alluvial formation. The flow in cavity well is spherical. The area of flow is increased by enlarging the size of the cavity. The tube well also is taken down till it penetrates the impervious, which is also called as bota layer, and reaches the water bearing layer. In the initial stages, when the water is pumped out, fine sand comes. I think it is repeated over here. So after cavity formation, only clear water enters the tube well. Since the rate of pumping is more, the velocity of water entering the coarse sand layer is critical. But when it comes in the hollow, the velocity is reduced. Finally, the water enters the tube well at the bottom with a velocity lower than the critical velocity. So how the development of cavity takes place? It is developed with the help of a centrifugal pump. It is generally adapted for developing a cavity well. And second, generally the depth of cavity well is a small, which is in centimeter. So you can see here the cavity type tube well. From ground level, it is constructed up to the clay layer, and further after formation of cavity, the water enters through the bottom in this type of well. So I hope you have understood the types of open wells, types of construction of open wells, tube wells and their construction. So I request all of you to go through these standard references to understand the concepts uh, precisely. If you are having any doubt, you can ask me on my email address dnpaitankar@sanjeevani.org.in. Thank you for listening. Happy learning.